It probably weighed 230 kilos and would have had to shift 90 liters of blood with a single beat. There's one.
The story of dinosaurs does not begin with dinosaurs themselves. It begins with catastrophe. Around 252 million years ago, Earth experienced the most devastating extinction event in the entire history of life. Known as the Permian mass extinction, this event erased nearly 90% of all species living in the oceans and about 70% of life on land. Entire ecosystems collapsed. Ancient forests vanished. Oceans lost most of their complex life. For millions of years afterward, the planet resembled a wounded world slowly trying to recover from an almost total biological collapse. The causes of this extinction were immense volcanic eruptions in what is now Siberia. These eruptions released enormous quantities of carbon dioxide and toxic gases into the atmosphere. Temperatures rose rapidly, oceans became acidic, and oxygen levels dropped. Many scientists describe this period as a planetary environmental crisis that pushed life to the edge of complete annihilation. When the extinction finally ended, the Earth that remained was almost empty. Vast ecological niches were left open. The dominant animal groups that had ruled the planet for millions of years were gone. This emptiness created the opportunity for new evolutionary experiments. The world that followed entered a period known as the Triassic. During the early Triassic, Earth looked very different from the planet we know today. All of the continents were fused together into a single gigantic landmass called Pangaea. This supercontinent stretched from pole to pole and was surrounded by a massive global ocean. Because of the enormous size of Pangaea, much of the interior of the continent was extremely dry. Rainfall rarely reached the center of the landmass. Large deserts stretched for thousands of kilometers. Rivers were seasonal and unpredictable. Temperatures fluctuated dramatically between scorching days and cold nights. Oxygen levels were lower than modern levels, making physical activity more demanding for many animals. In this harsh environment, life slowly began to rebuild. Among the survivors were a group of reptiles known as archosaurs. These animals would become one of the most important evolutionary groups in Earth's history. The name archosaur means ruling reptiles, though at this early stage they were far from rulers. They were simply one group among many trying to survive in a recovering ecosystem. Archosaurs possessed several key features that would later give their descendants important advantages. Their legs were positioned directly beneath their bodies rather than sprawled outward like most reptiles. This allowed them to move more efficiently and support larger body sizes. Their lungs were also highly effective at extracting oxygen, a useful adaptation in the low oxygen conditions of the Triassic atmosphere. Over time, the archosaurs diversified into several different evolutionary branches. One branch would eventually lead to crocodilians. Another would lead to pterosaurs, the flying reptiles that would dominate the skies. And one particular branch would give rise to dinosaurs. However, during the early Triassic, dinosaurs did not yet exist. The dominant land animals were a variety of reptilian groups, including large predators known as rauisuchians and armored herbivores that browsed the sparse vegetation. Meanwhile, mammal-like reptiles, descendants of ancient synapsids, continued to occupy many ecological roles. These animals were the distant relatives of the mammals that would one day dominate the planet. For tens of millions of years, dinosaurs had not yet appeared. Evolution was still experimenting with many different body plans and survival strategies. Around 235 to 230 million years ago, the first true dinosaurs finally emerged. These early dinosaurs were not the giants that people often imagine. They were small, agile animals that rarely exceeded the size of a large dog. Their bodies were built for speed and efficiency rather than brute strength. One of the earliest known dinosaurs was Eoraptor. This animal lived approximately 231 million years ago in what is now Argentina. Eoraptor was a lightweight predator, about 1 meter long. Its body structure already displayed many of the key features that define dinosaurs. Its legs were positioned directly beneath its body, allowing it to run quickly. Its hands possessed grasping claws useful for catching prey. Another early dinosaur was Herrerasaurus, a larger predator that may have reached lengths of up to 6 meters. Herrerasaurus possessed sharp teeth designed for slicing flesh and powerful hind legs built for running. Despite these impressive traits, dinosaurs were still relatively rare during the Triassic. They shared their world with many other reptilian groups that were often larger and more dominant. In fact, for much of the Triassic period, dinosaurs were far from the rulers of Earth. They were simply one evolutionary experiment among many. What gave dinosaurs their eventual advantage was a combination of biological efficiency and environmental opportunity. Their upright posture allowed them to move more efficiently over long distances. Their respiratory systems may have been more advanced than those of many competing reptiles, enabling them to remain active even in challenging conditions. But perhaps the most important factor was timing. Near the end of the Triassic period, Earth experienced another major extinction event. Around 201 million years ago, volcanic eruptions associated with the breakup of Pangaea released massive amounts of carbon dioxide into the atmosphere. These eruptions occurred along enormous cracks in the Earth's crust as the supercontinent began to split apart. The environmental consequences were severe. Climate instability spread across the planet. Rapid warming altered ecosystems. Many large reptilian competitors that had previously dominated the land began to disappear. Groups such as the Rauisuchians, once powerful predators, vanished during this extinction event. Numerous herbivorous reptile species also disappeared. Dinosaurs, however, survived. For reasons still debated by scientists, dinosaurs proved more resilient to the environmental changes that devastated other animals. Their efficient movement and possibly superior respiratory systems may have allowed them to adapt more successfully to fluctuating conditions. With their competitors gone, dinosaurs suddenly found themselves in a dramatically transformed world. Ecological niches that had previously been occupied by other animals were now empty. Forests, plains, and river systems were open for new inhabitants. Evolution began to accelerate. The stage was finally set for the rise of dinosaurs. During the earliest part of the Jurassic period that followed, dinosaurs began spreading rapidly across the landscapes of Pangaea. Small predators evolved into larger hunters. Early plant-eating dinosaurs diversified into a variety of body shapes, adapted for browsing different types of vegetation. Within a relatively short geological time span, dinosaurs transformed from minor members of the ecosystem into its dominant land animals. Yet at this early stage, they were still far from the giants that would later define the dinosaur age. Most species remained relatively modest in size. Ecosystems were still reorganizing after the extinction, but the evolutionary foundation had been laid. The world was changing. The continents were slowly beginning to separate. New climates were forming, new plants were spreading across the land. And among the animals adapting to this evolving planet, dinosaurs were proving to be uniquely successful. Over the next 200 million years, they would diversify into an extraordinary range of forms. Some would become the largest land animals that had ever existed. Others would develop armor, horns, and elaborate defensive structures. Some would dominate as apex predators. Others would evolve feathers and eventually take to the skies. The age of dinosaurs had begun, but its greatest chapters were still waiting to unfold. The small, fast-running animals that first appeared in the Triassic were only the beginning of a much larger evolutionary story. Their descendants would reshape the ecosystems of the planet for nearly 200 million years. And in the forests and plains of the early Jurassic world, the first steps toward that future were already underway. As the Triassic period came to a violent close around 201 million years ago, the planet entered a new chapter in its history. The extinction event that marked the boundary between the Triassic and the Jurassic had wiped out many of the reptilian groups that once dominated the land. In their absence, a new set of animals began to rise. Among them were the dinosaurs. At the start of the Jurassic period, Earth was still dominated by the massive supercontinent Pangaea. This gigantic landmass stretched across much of the planet, surrounded by a vast global ocean called Panthalassa. However, deep within the crust of the Earth, powerful geological forces were beginning to pull the supercontinent apart. Rifts began forming across the land. Massive cracks opened as tectonic plates slowly drifted away from each other. Over millions of years, these fractures would widen into new ocean basins, eventually creating the separate continents we know today. The climate of the early Jurassic was warmer and more stable than the harsh conditions of the late Triassic. Rainfall increased in many regions, allowing forests to expand across areas that had once been dry deserts. Ferns, cycads, and conifer trees began forming dense ecosystems that covered large parts of the landscape. These new plant communities created opportunities for large plant-eating animals to evolve. Dinosaurs were ready to take advantage of these changes. One of the most important developments during this time was the diversification of dinosaurs into three major evolutionary branches. These groups would dominate terrestrial ecosystems for the next 135 million years. The first group was the theropods. These were primarily meat-eating dinosaurs that walked on two legs. Theropods included many of the most famous predators in dinosaur history, though in the early Jurassic they were still relatively modest in size. The second group was the sauropodomorphs. These dinosaurs would eventually evolve into the enormous long-necked giants that defined the Jurassic world. But their early ancestors were much smaller animals that walked either on two legs or occasionally on four. The third group was the ornithischians. These dinosaurs were primarily herbivores and would later evolve into some of the most diverse plant-eating animals of the Cretaceous period. In the early Jurassic, these three groups began spreading rapidly across the landscapes of Pangaea. Among the theropods, early predators such as Dilophosaurus became some of the most formidable hunters of their time. Dilophosaurus lived around 193 million years ago and reached lengths of about 6 meters. It possessed long, slender legs that allowed it to run quickly across open terrain. Its jaws were filled with sharp teeth designed for slicing through flesh. Unlike the gigantic predators that would appear later in dinosaur history, early theropods were built for agility rather than overwhelming power. Their hunting strategy likely relied on speed and precision, allowing them to capture smaller prey animals that lived in the Jurassic forests. Meanwhile, the ancestors of the great sauropods were undergoing their own transformation. Early sauropodomorphs such as Plateosaurus had already appeared during the late Triassic. These animals were large compared to earlier dinosaurs, reaching lengths of up to 10 meters. However, they still retained the ability to stand on two legs and may have used their forelimbs to grasp vegetation. As the Jurassic period progressed, these animals began evolving even larger body sizes. Their necks lengthened, allowing them to reach higher into the trees. Their bodies became heavier, and their limbs thickened to support increasing weight. Eventually, this evolutionary path would lead to the first true sauropods. Sauropods were unlike any animals that had ever lived on land before. Their bodies were enormous, with long necks, massive torsos, and pillar-like legs that supported their immense weight. Even in the early Jurassic, these giants were beginning to reshape the landscapes they inhabited. Their feeding habits had a profound impact on the environment. By stripping leaves from trees and trampling vegetation beneath their feet, sauropods altered forests and created new ecological spaces for other animals. At the same time, ornithischian dinosaurs were quietly expanding their own evolutionary success. Early ornithischians were generally smaller herbivores that fed on low-growing plants. Many possessed specialized teeth that allowed them to process tough vegetation more efficiently than other reptiles. These animals played an important role in the Jurassic ecosystems by occupying feeding niches that larger dinosaurs could not easily exploit. As dinosaurs diversified, they began spreading across the entire supercontinent. Fossils from this period have been discovered in North America, South America, Europe, Africa, and Asia, showing that dinosaurs had already achieved a near global distribution. Their success was partly due to their biological design. Dinosaurs possessed efficient skeletal structures that allowed them to grow to large sizes while maintaining mobility. Their upright posture reduced energy loss during movement, making long-distance travel easier. Their respiratory systems were likely highly efficient, enabling them to sustain active lifestyles. These traits allowed dinosaurs to outcompete many other reptiles that shared their environment. But dinosaurs were not the only reptiles thriving during the Jurassic. While dinosaurs ruled the land, other reptile groups dominated the skies and oceans. In the air, pterosaurs became the first vertebrates to achieve true powered flight. These flying reptiles possessed elongated wings formed by a membrane of skin stretched between an extended fourth finger and the body. Early pterosaurs were relatively small, but they were highly skilled flyers capable of gliding across vast distances. Many fed on fish or insects, using their aerial abilities to access food sources unavailable to ground animals. Meanwhile, the oceans were inhabited by enormous marine reptiles. Creatures such as ichthyosaurs and plesiosaurs filled ecological roles similar to modern dolphins and large marine predators. Ichthyosaurs possessed streamlined bodies and powerful tails that allowed them to swim at high speeds through the water. Plesiosaurs had long necks and paddle-like limbs that enabled them to maneuver through the ocean in search of fish and squid. Although these animals were not dinosaurs, they lived alongside them and formed part of the broader reptilian world of the Jurassic period. Back on land, the continued breakup of Pangaea was slowly changing the geography of the planet. As continents drifted apart, new coastlines formed and climates began to vary between regions. These changes created isolated environments where dinosaur populations could evolve in different directions. This process of geographic separation would eventually lead to the extraordinary diversity of dinosaurs seen later in the Cretaceous period. But during the early Jurassic, dinosaurs were still establishing their dominance. Their populations expanded across forests, floodplains, and coastal regions. Predator and prey relationships became increasingly complex. Ecosystems stabilized after the chaos of the Triassic extinction. Dinosaurs were no longer minor participants in the story of life on Earth. They had become the central actors. Every major land ecosystem now included dinosaurs as either the dominant herbivores, the top predators, or both. Their evolutionary success was reshaping the balance of life on the planet, yet the true giants of dinosaur history had not fully emerged. The early Jurassic laid the groundwork for something even more extraordinary. Over the next tens of millions of years, dinosaurs would continue evolving into forms that pushed the limits of biology. Some would grow to sizes larger than any land animals before or since. Others would develop sophisticated defensive structures, social behaviors, and complex ecosystems. The Jurassic world was still young, but its future was already beginning to take shape. Dinosaurs had survived extinction, adapted to a changing planet, and spread across an entire supercontinent. Their empire was only beginning. By the time Earth entered the middle of the Jurassic period, roughly 170 million years ago, the world had transformed into a thriving and complex ecosystem dominated by dinosaurs. What had begun as small, fast-moving reptiles in the Triassic had now evolved into some of the most extraordinary animals the planet had ever seen. The Jurassic world was warmer and wetter than the one that existed before it. Across vast regions of the supercontinent Pangaea, forests spread in enormous green belts. Conifer trees towered above dense undergrowth filled with ferns, horsetails, and cycads. River systems carved their way through floodplains that stretched for hundreds of kilometers. In these fertile environments, plant life flourished, creating abundant food sources for herbivorous animals. With such resources available, evolution began pushing dinosaurs toward unprecedented sizes. This was the era when the first truly gigantic land animals appeared. Among them were the sauropods, the long-necked giants that would become the largest creatures ever to walk the Earth. Sauropods represented one of the most extreme examples of biological growth in the history of life. Their bodies were built like living bridges of muscle and bone. Long necks allowed them to reach high into the canopy of Jurassic forests, stripping leaves from trees that smaller herbivores could not access. Their tails extended behind them like enormous counterbalances, stabilizing their massive bodies as they moved. One of the most famous sauropods from this era was Diplodocus. This dinosaur could grow to lengths of around 27 meters. Its long neck contained dozens of vertebrae, each carefully shaped to maintain both flexibility and strength. Despite its enormous size, Diplodocus was relatively lightweight for its length due to hollow bones and air-filled cavities within its skeleton. Another iconic giant was Brachiosaurus. Unlike many other sauropods, Brachiosaurus had front legs that were longer than its hind legs. This unusual body structure tilted its body upward, allowing its neck to reach even higher into the treetops. With a height comparable to a 4-story building, Brachiosaurus could feed on vegetation that no other herbivore could reach. Then there was Apatosaurus, another enormous sauropod known for its thick body and powerful limbs. This dinosaur may have weighed more than 30 tons. Its massive neck allowed it to sweep across large areas of vegetation without needing to move its entire body, an efficient feeding strategy for an animal that required vast quantities of plant material every day. Scientists estimate that large sauropods may have consumed hundreds of kilograms of vegetation daily. To support such appetites, Jurassic forests needed to produce immense amounts of plant growth. The presence of these giants had a powerful effect on the landscape. As sauropods fed, they broke branches, knocked down smaller trees, and trampled vegetation beneath their feet. Their movements created natural clearings in forests, opening space for new plants to grow. In this way, sauropods acted as ecosystem engineers, shaping the environments in which they lived. But such enormous herbivores could not exist without predators capable of hunting them. The Jurassic period also saw the rise of powerful theropod dinosaurs that evolved specifically to prey upon large animals. Among the most formidable of these predators was Allosaurus. Allosaurus lived around 155 million years ago and grew to lengths of approximately 9 to 12 meters. Unlike the slender theropods of the early Jurassic, Allosaurus possessed a more robust body structure. Its jaws were lined with sharp, serrated teeth designed for slicing through flesh. Its arms were relatively short, but equipped with powerful claws that could grasp struggling prey. Its legs were strong and muscular, allowing it to move quickly despite its large size. Allosaurus likely hunted large herbivores, including young sauropods and other plant-eating dinosaurs that roamed the floodplains of the Jurassic world. Evidence from fossil sites suggests that Allosaurus may have occasionally hunted in groups, though this remains a topic of scientific debate. What is clear is that these predators played a crucial role in maintaining balance within Jurassic ecosystems by controlling herbivore populations. Another predator from this period was Ceratosaurus, a theropod known for the distinctive horn located on its snout. Ceratosaurus was slightly smaller than Allosaurus, but still a formidable hunter capable of taking down medium-sized prey. Together, these predators formed the apex level of the Jurassic food chain. Beneath them existed a wide variety of smaller dinosaurs that filled different ecological roles. Some were fast-moving herbivores that grazed on low vegetation. Others were agile predators that hunted insects, small reptiles, and juvenile dinosaurs. One of the most fascinating developments during this time was the appearance of feathered dinosaurs. For decades, scientists believed that feathers were unique to birds. But discoveries of exceptionally preserved fossils in China have revealed that many small theropod dinosaurs possessed feathers long before the first true birds appeared. These feathers were not always used for flight. In many species, they likely served as insulation, helping dinosaurs maintain stable body temperatures. Feathers may also have played roles in display and communication, allowing dinosaurs to signal to potential mates or intimidate rivals. One particularly important dinosaur from the late Jurassic was Archaeopteryx. Archaeopteryx lived approximately 150 million years ago and is often considered one of the earliest known birds. Its skeleton reveals a remarkable mixture of characteristics. It possessed feathers and wings capable of gliding or limited flight, but it also retained many dinosaur features, including teeth, a long bony tail, and clawed fingers. Archaeopteryx provided powerful evidence that birds evolved directly from small theropod dinosaurs. In other words, birds are not merely related to dinosaurs, they are dinosaurs. This discovery fundamentally changed how scientists understand the dinosaur lineage. It means that dinosaurs did not truly disappear when the age of dinosaurs ended. Instead, one branch of the dinosaur family tree survived and continues to exist today in the form of modern birds. While evolutionary innovations were occurring among dinosaurs, the geography of the planet continued to shift. The massive supercontinent Pangaea was gradually breaking apart into separate land masses. Vast rift valleys formed as tectonic plates slowly moved away from one another. Over millions of years, these rifts would widen into new oceans. As continents drifted apart, dinosaur populations became isolated from one another. This geographic separation encouraged the development of new species adapted to local environments. Different regions of the planet began developing unique dinosaur communities. In North America, vast floodplains supported enormous herds of sauropods and the predators that hunted them. In Europe, island chains created isolated ecosystems where smaller dinosaurs evolved in relative isolation. In Asia and Africa, new species emerged in response to changing climates and landscapes. The Jurassic world was becoming increasingly complex. By the late Jurassic period, dinosaurs had achieved a level of ecological dominance unmatched by any previous group of land animals. They filled nearly every major role in terrestrial ecosystems. Some were enormous herbivores shaping forests. Others were apex predators maintaining ecological balance. Smaller species hunted insects or scavenged for food along riverbanks. Feathered dinosaurs experimented with gliding and early flight. The skies were filled with pterosaurs, while the oceans teemed with marine reptiles. Life on Earth had entered a golden age of reptilian evolution, yet the story of dinosaurs was far from complete. Even greater diversity was waiting in the future. The next geological chapter, the Cretaceous period, would bring dramatic changes to the planet. New types of plants would transform ecosystems. Continents would drift even farther apart. Dinosaurs would evolve into forms more diverse and specialized than ever before. Some would develop armor strong enough to repel the largest predators. Others would grow elaborate horns and defensive structures. Herds of plant-eating dinosaurs would roam across vast plains. And among the predators, new hunters would arise that would surpass even Allosaurus in power. The Jurassic Age had revealed the potential of dinosaurs, but the greatest evolutionary explosion of dinosaur diversity was still yet to come. As the Jurassic period slowly came to an end around 145 million years ago, Earth was already a planet dominated by dinosaurs. For nearly 60 million years, they had shaped ecosystems across the supercontinent, Pangaea, and the newly forming continents that were slowly drifting apart. Yet the next chapter of dinosaur history would bring an explosion of diversity unlike anything the planet had seen before. This new era is known as the Cretaceous period. During the early Cretaceous, Earth continued to change both geologically and biologically. The ancient supercontinent Pangaea had now begun to split more dramatically. Large pieces of land were drifting away from one another, forming the early versions of continents such as North America, South America, Africa, and Eurasia. As these landmasses separated, oceans widened between them. New coastlines formed, creating different climates across the planet. Some regions became lush and humid, filled with dense forests. Others developed seasonal climates with open plains and river systems. This geographic separation played a major role in shaping dinosaur evolution. When populations of animals become isolated on different continents, they begin evolving independently. Over millions of years, these isolated groups develop unique characteristics that distinguish them from their relatives elsewhere. During the Cretaceous period, this process produced an incredible variety of dinosaur species. At the same time, a revolutionary change was occurring in the plant world. For most of the Jurassic period, Earth's vegetation had been dominated by ancient plant groups such as conifers, ferns, and cycads. These plants reproduced using spores or exposed seeds and had existed for hundreds of millions of years. But during the early Cretaceous, a completely new type of plant began spreading across the planet. These were flowering plants, known scientifically as angiosperms. flowering plants represented one of the most significant biological innovations in Earth's history. They produced flowers that attracted insects and other animals, which helped pollinate the plants. This allowed flowering plants to reproduce more efficiently and spread rapidly across many environments. Within a relatively short geological period, flowering plants began transforming entire ecosystems. Forests that had once been dominated by conifers now contained a growing variety of flowering shrubs and trees. New types of fruits and seeds appeared, providing new food sources for herbivores. Dinosaurs quickly adapted to this changing world. Many herbivorous dinosaurs evolved specialized teeth and jaws designed to process tougher vegetation. These adaptations allowed them to take advantage of the expanding diversity of plants. One of the most successful groups of plant-eating dinosaurs during the Cretaceous was the hadrosaurs, often called duck-billed dinosaurs. Hadrosaurs possessed broad, flattened snouts that resembled the bills of ducks. Inside, their mouths were hundreds of tightly packed teeth, arranged in structures known as dental batteries. These teeth functioned like complex grinding surfaces capable of crushing tough plant material. Because of these highly efficient chewing systems, hadrosaurs could process a wide variety of vegetation. This gave them a major evolutionary advantage. Many hadrosaurs also lived in large herds that could contain hundreds or even thousands of individuals. Fossil evidence suggests that these animals may have migrated across large distances in search of food and water, much like modern herds of grazing mammals. Living in large groups also provided protection from predators. But herbivores did not rely only on numbers for defense. Another remarkable group of dinosaurs that flourished during the Cretaceous were the ceratopsians. Ceratopsians were horned dinosaurs, and among them was one of the most famous dinosaurs of all time, Triceratops. Triceratops possessed 3 prominent horns on its head, along with a massive bony frill extending from the back of its skull. These structures likely served multiple purposes. The horns could be used to defend against predators, while the frill may have played a role in display, species recognition, or regulating body temperature. Triceratops and its relatives were powerful herbivores, capable of standing their ground against even the largest predators. Their strong jaws and specialized teeth allowed them to feed on tough plants that other dinosaurs might have struggled to consume. Another group of herbivorous dinosaurs that developed impressive defensive features were the Ankylosaurs. Ankylosaurs were heavily armored dinosaurs covered in thick plates of bone embedded within their skin. Some species also possessed large spikes along their sides, while others developed massive tail clubs that could deliver devastating blows. The tail club of Ankylosaurs functioned like a biological hammer. When swung with force, it could break the bones of attacking predators. This made Ankylosaurs among the most heavily defended animals ever to exist. Despite their fearsome defenses, Ankylosaurs were peaceful herbivores that spent most of their time grazing on low vegetation. Another group of armored dinosaurs known as stegosaurs had already appeared during the Jurassic period, but by the Cretaceous, they were declining in diversity. Their place was increasingly taken by Ankylosaurs and other specialized herbivores. As herbivores diversified, so did the predators that hunted them. The Cretaceous period produced some of the most sophisticated and specialized carnivorous dinosaurs ever to exist. Among them were the dromaeosaurs, a group of agile predators that included animals such as Velociraptor. Unlike the enormous predators that would appear later in the Cretaceous, dromaeosaurs were relatively small but extremely intelligent and fast. They possessed sharp claws on their feet, including a distinctive sickle-shaped claw that could be used to slash at prey. Their bodies were covered in feathers, reinforcing the evolutionary connection between dinosaurs and birds. Dromaeosaurs may have hunted in coordinated groups, though this behavior is still debated among scientists. If true, such cooperation would have allowed them to take down prey larger than themselves. The growing complexity of predator and prey relationships during the Cretaceous created ecosystems filled with constant evolutionary competition. Herbivores evolved stronger defenses. Predators evolved sharper senses and more powerful hunting strategies. Meanwhile, the skies above these landscapes were filled with flying reptiles. Pterosaurs had existed since the Triassic period, but during the Cretaceous, they evolved into some of the largest flying animals in Earth's history. One extraordinary example was Quetzalcoatlus. With a wingspan estimated at over 10 meters, Quetzalcoatlus was roughly the size of a small airplane. Despite its enormous wings, it was capable of launching into the air and gliding across vast distances. These giant pterosaurs likely fed on small animals, fish, or carrion along coastal environments and inland plains. While pterosaurs dominated the skies, a different kind of flying dinosaur was also becoming increasingly successful: birds. The descendants of feathered theropods continued evolving throughout the Cretaceous. Early birds became more specialized for flight, gradually losing many of the dinosaur traits that their ancestors had possessed. They developed shorter tails, stronger flight muscles, and beaks adapted for different diets. These early birds occupied ecological roles similar to modern birds, feeding on insects, seeds, and small animals. By the middle of the Cretaceous period, the planet was filled with extraordinary diversity. Gigantic herbivores roamed forests and plains. Armored dinosaurs defended themselves with spikes and clubs. Swift predators hunted through dense vegetation. Feathered dinosaurs glided or flew above the landscape. Dinosaurs had now reached the peak of their evolutionary success. For over 100 million years, they had dominated the land with remarkable adaptability and diversity. They had survived environmental changes, continental shifts, and intense evolutionary competition. Yet despite their success, the age of dinosaurs was approaching its final chapter. Though magnificent, would not last forever. By the time Earth entered the late Cretaceous period, roughly 100 million years ago, the age of dinosaurs had reached its most dramatic and complex stage. For more than 150 million years, dinosaurs had evolved, adapted, and diversified across the planet. Now their ecosystems had become some of the most advanced and specialized biological systems Earth had ever seen. The continents that were once united within the supercontinent Pangaea were now clearly separated. North America had drifted away from Europe. South America was separating from Africa. India was beginning its long journey northward across the ocean. Vast inland seas flooded portions of continents, dividing landmasses and creating new coastal environments. These geographic changes reshaped dinosaur habitats. In North America, a massive, shallow ocean called the Western Interior Seaway split the continent into two long landmasses. This sea stretched from what is now the Arctic Ocean all the way down to the Gulf of Mexico. On either side of this inland ocean, lush coastal plains formed environments rich with vegetation and wildlife. These fertile lands supported enormous dinosaur populations. The ecosystems of the late Cretaceous were filled with towering herbivores, powerful predators, and an astonishing variety of smaller species. Among the most famous animals of this era were the horned dinosaurs known as ceratopsians. Ceratopsians had evolved from smaller ancestors earlier in the Cretaceous, but by the late Cretaceous, they had become some of the dominant herbivores of North America and parts of Asia. The most iconic member of this group was Triceratops. Triceratops was a massive herbivore that could grow up to 9 meters long and weigh several tons. Its most recognizable feature was its skull, which carried 3 large horns and a huge bony frill extending behind its head. The 2 long horns above its eyes could grow more than a meter in length. These horns were likely used both for defense and for combat between members of the same species. Fossil evidence suggests that Triceratops individuals sometimes fought each other, possibly competing for mates or territory. The large frill on the back of the skull may have served multiple purposes. It could have helped anchor powerful neck muscles used when lowering the head to graze. It may also have played a role in display, allowing individuals to visually communicate strength and health. Triceratops herds likely roamed across open plains, feeding on the abundant vegetation that covered the land. But these great herbivores lived under constant threat from one of the most formidable predators in Earth's history of earlier theropods. Instead, they were built to crush bone. Recent scientific studies estimate that Tyrannosaurus Rex possessed one of the strongest bite forces ever measured in a land animal. Its jaws could exert pressure exceeding 30,000 newtons, powerful enough to shatter the bones of large prey. Its powerful legs allowed it to move quickly despite its enormous size, and its tail acted as a counterbalance to maintain stability while running. Although its arms were small, they were extremely muscular and tipped with sharp claws. These arms may have helped the animal hold struggling prey while delivering fatal bites. Tyrannosaurus Rex likely hunted large herbivores such as Triceratops and Hadrosaurs, though it may also have scavenged carcasses when the opportunity arose. The presence of such a dominant predator had a major impact on the structure of late Cretaceous ecosystems. Herbivores evolved stronger defenses and social behaviors to protect themselves. Large herds allowed animals to detect predators earlier and defend vulnerable individuals. Among the most successful herbivores of this time were the hadrosaurs. Hadrosaurs, also known as duck-billed dinosaurs, were incredibly abundant across many parts of the world. These dinosaurs could grow up to 10 meters long and were equipped with highly specialized mouths capable of processing large quantities of plant material. Inside their jaws were hundreds of teeth arranged in tightly packed rows. As older teeth wore down, new ones continuously replaced them. This dental system functioned like a complex grinding machine, allowing hadrosaurs to chew tough vegetation efficiently. Many hadrosaurs also possessed elaborate crests on their heads. These crests varied in shape and size between species. Some were solid structures of bone, while others contained hollow chambers connected to the nasal passages. Scientists believe these crests may have helped produce resonant calls that allowed herds to communicate over long distances. Large herds of hadrosaurs could have numbered in the thousands, moving across floodplains in search of food. But not all herbivores relied on numbers alone. Some evolved extreme defensive structures that made them almost impossible for predators to attack. One of the most heavily protected dinosaurs of the late Cretaceous was Ankylosaurus. Ankylosaurus was a low, heavily armored dinosaur that could grow around 8 meters long. Its body was covered in thick plates of bone known as osteoderms. These armored plates formed a protective shield that covered its back, sides, and even parts of its eyelids. The most remarkable feature of Ankylosaurus was its tail club. At the end of its tail was a massive knob of solid bone formed from fused vertebrae and thickened bone plates. This structure could be swung with enormous force. Scientists believe that a well-placed strike from an Ankylosaurus tail could break the leg bones of a large predator. This made attacking such an animal extremely dangerous. As a result, Ankylosaurus likely spent much of its life grazing peacefully on low vegetation, protected by its living armor. While massive predators and herbivores dominated the landscape, many smaller dinosaurs continued to thrive as well. Among these were feathered theropods closely related to the ancestors of birds. Animals such as dromaeosaurs were fast, intelligent predators, equipped with sharp claws and strong jaws. Their bodies were covered in feathers that may have helped regulate body temperature or played roles in communication. Some of these dinosaurs possessed wings that allowed them to glide between trees or perform short bursts of powered flight. During the late Cretaceous, the evolution of birds accelerated significantly. Early birds became more specialized for flight. Their skeletons became lighter. Their wings became more efficient. Their tails shortened and fused into structures that improved aerial control. These animals spread across forests, wetlands, and coastal environments, feeding on insects, seeds, and small animals. While dinosaurs dominated the land and birds filled the skies, the oceans were ruled by enormous marine reptiles. Creatures such as mosasaurs became the apex predators of the seas. Mosasaurs were powerful swimming reptiles that could grow over 15 meters long. Their bodies were streamlined for life in the water, with paddle-like limbs and powerful tails. They hunted fish, ammonites, and even other marine reptiles in the warm oceans of the Cretaceous world. By the final millions of years of the Cretaceous period, Earth's ecosystems had reached an extraordinary level of complexity. Dinosaurs had become the dominant land animals across every continent. They filled roles as grazers, browsers, predators, scavengers, and specialized feeders. Birds were spreading through the skies as descendants of feathered dinosaurs. Mammals remained relatively small, but were quietly evolving in the shadows. For more than 160 million years, dinosaurs had ruled the land with unmatched success. Yet their dominance would soon face a challenge unlike anything they had encountered before. A single cosmic event was approaching that would reshape the entire history of life on Earth. An event that would bring the age of dinosaurs to its dramatic end. By the final moments of the Cretaceous period, about 66 million years ago, the planet had become a thriving world filled with life. Dinosaurs dominated the land across nearly every continent. Herds of enormous herbivores moved through forests and floodplains. Apex predators like Tyrannosaurus Rex hunted across open plains. Feathered dinosaurs and early birds filled the skies, while mammals lived quietly in burrows and dense vegetation. For more than 160 million years, dinosaurs had shaped the ecosystems of Earth. They had survived climate changes, shifting continents, and millions of generations of evolutionary competition. Their reign had lasted longer than the entire history of humanity. But this extraordinary age of dinosaurs was about to end. The cause of their downfall came not from within the Earth, but from space. Far beyond the atmosphere, a massive asteroid had been traveling silently through the solar system for millions of years. Measuring roughly 10 kilometers in diameter, this ancient rock was a remnant from the early formation of the solar system. Eventually, its orbit intersected with Earth's path. 66 million years ago, the asteroid entered Earth's atmosphere at incredible speed. Scientists estimate that the object was moving at more than 20 kilometers per second. As it plunged toward the surface, the friction with the atmosphere caused it to heat rapidly, turning the sky into a blazing streak of light, brighter than the sun. Within seconds, the asteroid slammed into the planet near what is now the Yucatan Peninsula in modern-day Mexico. The impact site is known today as the Chicxulub crater. The collision released an amount of energy equivalent to billions of nuclear bombs detonating at once. In a single moment, the surface of the Earth was violently reshaped. Rock beneath the impact site instantly vaporized. A crater nearly 180 kilometers wide was blasted into the crust of the planet. Shock waves radiated outward across the surrounding continents with unimaginable force. Everything within hundreds of kilometers of the impact site was instantly destroyed. Forests were flattened, mountains shook violently. Animals caught near the explosion would have died almost instantly from the intense heat and pressure. But the devastation did not stop there. The impact launched enormous quantities of molten rock and debris high into the atmosphere. Some of this material was thrown so far that it escaped the atmosphere briefly before falling back toward Earth. As these fragments re-entered the atmosphere, they heated up again, creating a rain of fire across vast regions of the planet. Many scientists believe this process ignited global wildfires. Forests across entire continents may have burned as glowing debris rained down from the sky. At the same time, the impact triggered massive earthquakes that shook the planet. Some of these seismic waves may have reached magnitudes greater than anything recorded in human history. Meanwhile, enormous tsunamis formed in the oceans. The asteroid had struck a shallow sea environment, displacing massive amounts of water. Towering waves, hundreds of meters high, surged outward from the impact zone, crashing against coastlines thousands of kilometers away. Yet the immediate destruction was only the beginning of the disaster. As dust, ash, and vaporized rock filled the atmosphere, the planet began entering a period of environmental collapse. The material thrown into the upper atmosphere blocked sunlight from reaching the surface. Within weeks, the skies grew dark. Temperatures dropped rapidly as sunlight became scarce. Plants, which depend on sunlight for photosynthesis, began to die. Without plants, herbivores lost their food sources. As plant-eating animals disappeared, the predators that depended on them soon followed. Entire food chains began collapsing. Dinosaurs, particularly the large species that required enormous amounts of food, were especially vulnerable to these sudden environmental changes. Large herbivores like Triceratops and Hadrosaurs depended on vast amounts of vegetation to survive. When plant life began dying off, their populations declined rapidly. Predators such as Tyrannosaurus Rex depended on these herbivores for food. As prey became scarce, even the most powerful hunters could not survive. Within a relatively short period of geological time, most dinosaur species vanished from the planet. But not all life was destroyed. Some animals possessed traits that helped them survive the catastrophe. Small mammals, for example, were able to hide in underground burrows where they were protected from heat and falling debris. Many mammals were also omnivorous, meaning they could eat a wide variety of foods, such as seeds, insects, and carrion. This flexible diet allowed them to survive in an environment where food sources were unpredictable. Another group of survivors were birds. Birds were the descendants of small feathered theropod dinosaurs that had evolved during the Jurassic and Cretaceous periods. Unlike their large dinosaur relatives, many birds were small and capable of flight. This mobility allowed them to escape dangerous environments and search for scattered food sources. Some birds also fed on seeds, which could remain available even after many plants had died. Because of these advantages, a number of bird species survived the extinction event. In fact, Every bird alive today is a direct descendant of the dinosaurs that survived the asteroid impact. The extinction event at the end of the Cretaceous is known as the Cretaceous Paleogene extinction. It marked the end of the age of dinosaurs, but it also opened the door for a new chapter in the history of life. With the giant dinosaurs gone, ecosystems across the planet were suddenly filled with empty ecological roles. Over the next millions of years, mammals began expanding into these roles. Small mammals evolved into larger herbivores, predators, and eventually the ancestors of modern animals such as whales, elephants, and primates. Among those primates would eventually appear a species capable of studying the ancient past, humans. Through the study of fossils, geology, and modern science, humans have been able to reconstruct the incredible story of dinosaurs. From their humble beginnings as small reptiles in the Triassic to their rise as the dominant animals of the Jurassic and Cretaceous, dinosaurs ruled the planet for an astonishing span of time. Their story is one of evolution, adaptation, and survival across nearly 200 million years. And although the asteroid brought the reign of giant dinosaurs to an end, their legacy did not vanish completely. Every bird that flies across the sky today carries within it the evolutionary heritage of the dinosaur age. The age of dinosaurs may have ended, but in a very real sense, dinosaurs never truly disappeared. They are still here, living, flying, and surviving in the modern world as the final descendants of one of the most extraordinary chapters in the history of life on Earth.